All right, we might get started. So this morning we have Capel Brunker, who has focused on core design concepts to provide scalable, efficient and robust software solutions. Today he'll be talking to us about inviting code. Give it up for him.
Hey everyone, inviting code. The idea for this talk is to turn your product, or if your product is probably already like this then you don't need to worry, but hopefully that you'll take something from this talk, to turn your product into an easy piece of framework that other people can utilize, that will allow other developers to quickly have a look at your product, know exactly what they're going to be doing when writing a plugin or a feature, and then getting to it. So we'll see how this develops. There is a brief code example in this talk, and that's from Zagami, which is a metadata project funded by Oxford University. So I'm sure we've all had this problem. In projects, you run into complications when you have a slightly complex system and you're taking in code input from other areas, from people that aren't a part of your core development team, or perhaps are juniors in your core development team. And that means code reviews, merging, possibly rejecting code, and also ensuring that the code is up to snuff, basically, whether it follows your formatting requirements or not, the whole back and forth. Obviously, code reviews can be used to mentor juniors, but this is more about code review on externally created code. So, and then also we run into the problem of feature addition requests, whether they're coming from project managers or from clients in general, wanting various features, wanting them now, or just people in general who are using your product, wanting features ready and available when you don't have the time allocated or it's just not in your current timeline. So with these, we've seen in various open source examples where project forking starts to happen because people want those features, they want them now, but the core developers just don't have the time for it. So the project gets forked. And then you get this fragmented structure where you have multiple projects with similar features and the user base is then spread across because they're trying to get all the different features. When you're also incorporating code, whether from third party or not, into your core product, because you need those additional features, you're creating a more complex code base. And that also leads to the problem of more features, more documentation, more features, more unit testing, and whether or not you have a fantastic workplace that allows you to spend as much time as required on testing frameworks and documentation is really the relevant point. So what if we could just remove all of those obstacles? What if we could have code addition without review? What if we could just add features willy-nilly into the product and the core developers don't even really need to know about it? They don't need to care about it. It's just a feature that gets added. Everyone's happy. If all the features get added, then your code forking or your project forking is not really an issue anymore because your project has the features. It's not as though your project is lacking the features and somebody's then forking your project to get the features. It's just done because you're not rejecting code anymore. You're not worrying about the code review. You don't have that overhead. And the use cases and documentation, well, they'll just take care of themselves. Don't even need to worry about it. It'll just be done. So how do we create this solution that automatically takes care of itself? And the idea here is to segment your core product from your features. So essentially you have your core application, and in areas where you think there's going to be feature addition, you start creating, say, a framework structure for it that can be modified. And then you've got a nice little flowchart here, obviously. The great thing about this is that when a plugin developer decides that they want a new feature for your product, they go ahead and create it. And it's now their problem to do the proper documentation, to do the testing, to do the stability, to make sure that it works with everything else in your system, hopefully through unit tests. And if anybody has any questions, they can ask that developer directly. It's no longer the responsibility of your core development team for this feature that this person has created, or that was perhaps on your timeline. And now you just have a third party taking care of that problem for you. Yes, that may create some additional problems if they don't have very good developers or they don't have very good documentation, then their product's not going to get used. But if it is a product, a feature that is being used heavily, that isn't written well or has bad documentation, your core developers can then put that on their timeline. And they can implement their own version that will be supported. But it gives you the option to say, new feature, go for it, create it, it's your responsibility. If it works, fantastic. If it doesn't, so be it. So that's where we come into the plugin framework. So creating the plugin infrastructure to allow this segmentation can be done with the inbuilt Python tools that are available to us. With simple solutions like using abstract classes to enforce the methods of your framework, and to have an abstract class for each, or abstract classes for each of the feature areas that you have segmented across. And the idea here is to make things as self-documentated as possible so they don't have to go to external solutions. They can look at the code themselves to work out exactly what the methods do, what the use cases are, as in what methods get executed where and in what order, or if they're standalone. And also, providing decent examples of your own plugin infrastructure is also going to be helpful when they're working examples. So I've just got a little note here that says abstract classes enforce methods for instantiated objects only. So if you're actually utilizing a singleton and you're not creating an object of the class, then you're not going to have that enforcement happen. It's just, you can use the class methods directly. So as I was talking about, segmentation of the core product from the core features. So this is an example of the Zagami product, where the areas were defined that would be dynamic or that could have additional features. So authentication, for example, now has LDAP support. So you can authenticate users against Active Directory and Open LDAP or AAF, which is utilised by universities across Australia and elsewhere, and a standalone localised solution. And you can basically just load these up as need be through a configuration file or similar. And some other areas also segmented for processing and metadata collection and things like that, grabbing directly from a database or grabbing from a file system or doing whatever needs to be done. This example is just showing where those areas were singled out that would be dynamic, that people would want to change, and then create it into a plugin structure. And this has been done in other areas, such as image libraries, utilising VIPs or utilising PIL directly. So this leads me to function annotations, because we're talking about class creation now. We're talking about the creation of the framework that people are going to use. So function annotations, I think, were introduced in Python 3.0. They're not really heavily utilised. However, they do offer a lead into what is a big step forward in this type of area in Python 3.5 called type hints, which we'll get to later. So function annotations basically allow you to quickly express what a parameter is going to be and what a return type is going to be in the code. So we'll just have a quick look at some code examples here. Right. So this is just a normal standard class that you could call a parent class, a base class that's going to be used. As you can see, it's got a normal constructor, it's got a class method. There's not much to say about it. It's got doc strings, as any decent class should have. It talks about the parameters, the return types as well. Some places it talks about that it's going to be returning a dict. Some places just saying, I'm returning an iterable container. And it's fairly fast and loose with how it's actually operating. It's more up to the developer to kind of work out exactly what's going to be returned, unless there's an exact example in the doc string. So if we go from this example to an annotated example, we can see a few minor differences. First of all, this is inheriting the meta class of ABC metadata, ABC being the abstract class module. Inheriting that, it can use abstract class methods, as you can see here as a decorator. And that just means, as I talked about previously, when you create the class object, it just checks to make sure that every single abstract class from the parent has actually been defined in the child. So this is what I was leading to with the function annotations, is the simple code addition of colon type. You can easily just say, this is going to be a string. Simple. Now people know directly that this parameter is a string, or is expected to be a string. It's not enforced. And here in the validation class method, it's expected, the field parameter is expected to be a dict. And it's also expected to return a dict. And the syntax here is just so easy that it begs the question, why not do it unless you've got a completely dynamic object? Why not express in the method signature exactly what the parameter and the return type is? Makes sense. Now these are basic types that can be shown easily. See here, the parameter says just an iterable of dictionaries containing, but you can see here that it actually needs to be a mutable iterable, being a list, not a tuple, or a set, or a frozen set. So this is just the comparative example against the base class that we showed, and now the annotated class. It's not that much extra information. It doesn't take time to write, but it's expressive. It can allow people to quickly understand what you're expecting to be returned. So if we actually go into a child class example, you can even get further information from the function annotations because it creates a private attribute that can be obtained. But anyways, so this is the example of a child plugin, or a plugin using the engine itself. It just implements the abstract methods as required. And this is just a quick example of function annotation with the default value. So when using a decent IDE, like for example PyCharm, it will actually inspect the class for you. So in the validation method itself is expecting, let's have a quick look. The validation method itself for the field value is expecting a dict. So when somebody's writing code for it and they decide that they're going to put in a list, they'll at least be notified. The expected type is a dict. You're putting in a list. You're probably going to end up with issues. The same with the constructor was expecting a string. You're putting in an int. You're going to get a little warning. And that's just helpful development tools integrated into the IDE that lead into function annotations and type hinting. Here, for example, obviously that's a valid object to be passed. Now, the interesting side effect of this is, for example, here we're concatenating a string with what's returned from delete. Now, delete returns in the function annotation returns a Boolean value, so it's saying, look, you're expecting a string, but you got type bool instead. You're going to have a bit of a problem. If we go up to the method itself, we can see that the method is actually returning a string. But that's not what the IDE is representing. It's saying, no, well, actually the framework itself is stating that you should be returning a bool. So even though you're doing the wrong thing in your class, it's going to show up when you're writing your code elsewhere in your unit tests or otherwise. So the annotation syntax has a precedent over the actual return value itself, allowing that cascading effect from your framework to their plugin, to their tests, to their usage. So now that we have a framework and we have plugins, and we have potentially plugins that we don't know nothing about that could break on load, that could have all sorts of problems, then you have to have a little bit more structure than possibly just the class itself. So you have a plugin manager, and the plugin manager has quite an important job. You can verify various module attributes, and I think in the example that I showed, it had some attributes such as the version number, the brief description, which could feed into a web suite list or something like that. Or, for example, the plugin manager could look at the module itself and say, hey, you've actually got a newer version available because that's what we're seeing. Would you like to load that in place in memory of what you've currently got? And it can also ensure that the required abstract classes are actually utilised by the plugin, because what's stopping somebody from saying, oh, I'm not really going to use your framework, I'm not going to use your abstract class, I'm just going to just chuck in my own, not inheriting anything, and you're going to load it. Well, you could theoretically have the manager inspect the parent class to ensure that you are loading, say, an image source plugin, that it is inheriting from the abstract method in your framework for image plugins. You can enforce all of these additional checks to make sure that your plugin is essentially a valid one. And of course, the plugin manager is there to ensure that when you load the plugin, if there's something horrible like a syntax problem or something stopping it from loading, at least it's going to basically catch it. It's going to log it, and it's not going to cause your problem to fail, your system to fail. So safe plugin loading is a pretty important aspect of the plugin manager. And this leads into plugin security, which I think is an interesting aspect, because it's, from what I've seen on the enterprise level for Python, there doesn't seem to be much focus on security for code. Then you have investors talking about, oh, but people can see your code. So what you can actually offer are things like digital signatures for plugins, and having a list of registered developers, and checking the signature of the modules on load and not loading them based on whether they exist in your signature vault, or just showing, hey, you're loading an unregistered or insecure, a possibly insecure plugin. And you can do that utilising whatever digital signature algorithm you want, GPG, PGP, NACL, library. So in order to do this sort of additional security, you can do something pretty cool with the newer versions of Python. In Python 3, you can create your own importer, essentially. So when you type the statement import Bob's plugin, it utilises the internal importer modules to handle all of that. But you can actually override them or insert your own. So you could have your own sourceless module loader, load modules directly from a Redis database stored in there. You could have your customized loader verify signatures of the source code before actually loading it and handling it however you want. And you could also go as far, if you want, to encrypt the modules and have your own customized format, or have your own open format, but just with a lot of, say, documentation at the start inbuilt into the actual file itself. Although that's not going to pass any tests that you run directly just using Python itself, you have to use your inbuilt loader in order to load the module. So that's pretty cool stuff, I reckon. So I briefly touched on type hints when I was talking about function annotations. Type hints are the whole new world of statically laying out how your framework is supposed to be used. Now, I know that a lot of Python developers aren't really too fond of static typing, and I think there's always the right tool for the job, and in some cases, static typing is actually probably a good thing. in a restrictive environment such as a framework that you want people to develop with, then using static typing to enforce parameter types or to enforce return types can actually help maintain a nice plugin environment. Make sure everything works the way that it's supposed to work. And that way you don't have to worry so much about people making plugins because it's their business. They have to do it a particular way. It's going to adhere to your standards. Just let it do its thing. So the function annotation syntax basically leads directly onto how type hints are going to work. So you can implement function annotations now utilizing types. And then in Python 3.5, when type hints come out, you can roll over to type hints quite easily. And it is, like I said, it's its whole, you could have a 2-hour talk on type hints, the way that they've actually designed it. It's quite large, so have a look at the PEP if you have time. It allows you to, instead of having, say, multiple class methods with different signatures, because you want to have different parameter types, you can actually just use the type var class that allows you to say, this parameter can be an int or a string, but only those two things. You can have some dynamic capabilities in there, even though it is statically typed. The typing module itself is very interesting. It allows you to essentially create your own templates of objects, and then we'll inspect the object pass of the parameter based on the template that you create, which is pretty cool. So for everybody who didn't want to use Python because of static types, well, now they don't have that excuse because it is there if they want to use it. So that's essentially the end of my talk. My aim here was just to try and open up the possibility of allowing people to add to your projects without having to worry about them so much, without having that overhead. Just having the chance to say, hey, yeah, sure, if you want to write some weird, bizarre thing, go for it. It's not going to affect your code base. It's just going to allow them to have this crazy feature. So I don't see why not. Allow them the flexibility to do what they want as long as it doesn't affect your core product, as long as it doesn't increase the code complexity of your product, as long as you don't have to write the bloody documentation for it. So that's what I wanted to put forward. I hope that came out as well as I intended. And if you guys have any questions, then please feel free.
Do we have any questions? Yep.
Hi, thanks for the talk. Have you gone through with implementing a custom importer, and was that as tricky as it sounds?
It's actually pretty straightforward. I think they need a little bit more documentation. It wasn't that hard. What I did was actually what I talked about, and I implemented a encrypted module solution that so people can't easily view the source code, essentially, that decrypts the module on the fly and enforces that module, that importer over every other importer, and also validates the importer code in another area to ensure that my importer is what I think it is. But the actual implementation itself, once you just lay it out, it's actually pretty simple. And you can inherit from the multiple classes of, is this going to be source code or is this going to be byte compiled code as well? So you can choose whether you're only going to support source code based files or if you're going to also support binary based files as well. So yeah, I think it's easy enough. I think you should go for it. Check it out.
Anyone else? Yep.
Hey, I'm quite a Python noob myself, but I have looked at doing plugins. You've mentioned how you structure your interface with abstract base classes. How, this may be a stupid question, but how do you get your program to detect what plugins are available or things like that?
You can do it through different ways. I mean, you can have a basic configuration file that the sysadmin or your web interface list the plugins in. You know, using config parser as a structured format, you can say, these are my file system plugins, or these are my image source plugins or authentication plugins. Or if you wanted to, if you've got a directory structure, then you could just say, you know, plugins, type, and then just scan the directory to see what's in there. I think there's lots of ways just to automatically detect whether plugins are there. It depends on how strict you want to be with the plugins, with the versions like I talked about, how you could have a look at the module and say, this version number, does it relate to the version number we're using in our configuration file? Do we really want to load it if it's a newer one? Things could have changed. Yeah.
Okay, anyone else? No? All right. Well, we've just got a token of thanks. This is a pycon-au mug for 2015.
Thanks. Lovely.
That's all right. One more round of applause.